guys, welcome to my YouTube channel. This course is a comprehensive guide to Java language describing its syntax, keywords and fundamental programming principles. This, this contains significant portions of Java API libraries, and this course is divided into four parts, each focusing on a different aspect of Java programming environment. The part 1 presents the in-depth tutorial of Java language at the beginning of the history and the evolution of Java, including things such as data types, operators, control statements, and classes. So this is episode 1 of our part 1 series. So let's start with this. Our first episode will contain the history and evolution of Java. So in this we are talking about the Java. To understand Java, one must consider and understand the reason behind its creation, the forces that shaped it. Although Java has become inseparably linked with online environments on the internet, it is important to remember that Java is the first and foremost a programming language. Computer language innovation and development occurs for two reasons. First is to adapt to changing environment and users, and second, to implement refinement and to improve the art of programming. So Java is related to C++, which is a direct descendant for C. Much of the characters of Java is inherited by these two languages, that is C and C++. In fact, several of Java's defining characteristics come from or are response to its predecessors. Moreover, the creation of Java was deeply rooted in the process of refinement and adaptation. Java was developed to meet some requirement of programmers which at that time C and C++ doesn't meet. As you will see, each innovation in language design was driven by the need to solve the fundamental problem that the preceding languages could not solve. Java is no exception. The birth of the modern programming, C. The C language shook the computer world. Its impact should not be underestimated because it fundamentally changed the way programming was approached and thought about. The creation of C was a direct result of the need for a structured, efficient, high-level language that could replace assembly code when creating system programs. Prior to C, programmers usually had to choose between languages that optimize set of traits or the other. For example, although Fortran could be used to write fairly efficient program for scientific application, it was not very good for system code. And while BASIC, a programming language, was easy to learn, but it was not very powerful, and its lack of structure made its usefulness questionable for large programs. Another compounding problem was that early languages such as BASIC, COBOL, and Fortran were not designed around the structured principle. As a result, programs written using these languages tended to produce spaghetti code, which means a mass of tangled, jumped, and conditional branches that make a program virtually impossible to understand. To solve this problem, the CBOS came into picture. Since C was useful and successful because of its structured design, it was developed. It was invented by Dennis Ritchie on DEC PDP-11 machine running with Unix operating system. C was the result of development process that started with an older languages called BPCL developed by Martin Richard, which influenced language B invented by Ken Thompson and which led to the development of C in 1970s. During the late 1970s and early 1980s, C became the dominant computer programming language and still widely used today. Since C is a successful and useful language, you might ask why a need for something else existed. The answer is complexity. Throughout the history of programming, the increasing complexity of programs has driven the need for better ways to manage their complexity. C++ is a response to that need. Approaches to programming have changed dramatically since the invention of the computer. For example, when computers were first invented, programming was done by manually toggling the binary machine's instruction by the use of front panel. The first widespread language was of course Fortran. While Fortran was impressive first step, at that time it was hardly a language that encouraged clear and easy way to understand programs. In 1960s gave birth to structured programming language. This method was championed by the language such as C. The use of structured method of programming enables the programmer to write the first time moderately complex programs. However, even the structured programming method, once a program reaches a certain size, its complexity exceeds what a programmer cannot manage. By the early 1980s, many projects were pushing the structured approach past its limits. To solve this problem, a new way of program was invented called as object-oriented programming (OOPS). The object-oriented programming is discussed in detail later in this course, but here is a brief definition that OOP is a programming methodology that helps organize the complex programs through the use of inheritance, encapsulation, and polymorphism. Although C is one of the world's greatest programming language, there is a limit to its ability to handle complexity. C++ added features that enable these thresholds to be broken, allowing programmers to comprehend and manage larger programs. C++ was invented by Bjorn Stroustrup in 1979 while he was working at Bell Laboratories in Murray Hills, New Jersey. He initially called the new language C with classes. However, in 1983, the name was changed to C++. The C++ extends C by adding object-oriented features. The invention was not an attempt to create a completely new programming language. Instead, it was an enhancement to an already highly successful one. After the invention of C++, the stage is set for Java. By the end of 1980s and early 1990s, object-oriented programming using C++ took hold. Indeed, for a brief moment, it seemed as if programmers had finally found a perfect language because C++ blended with high efficiency and stylistic element of C. However, just as in past, forces were brewing that would once again drive computer language evolution forward. Within a few years, the World Wide Web and Internet would reach critical mass. This event would participate another revolution in programming, that is, the creation of Java. Java was conceived by James Gosling, Patrick Norton, don't know what his name is, Chris Wyeth, Ed Frank, and Mike Sheridan at Sun Microsystems Incorporations in 1991. It took 18 months to develop the first working version. Somewhat surprisingly, the original impetus of Java was not the Internet. Instead, the primary motivation was the need for a platform-independent, that is, an architecture-neutral language that could be used to create software to be embedded in various consumer electronic devices, such as the microwaves, ovens, and the remote controls. As you can probably guess, many different types of CPU are used as controllers. The trouble with C and C++ and most other languages is they are designed to be compiled for a specific target. Although it is possible to compile a C++ program for just about any type of CPU. To do so, you will require a full C++ compiler to the targeted CPU. The problem is soon solved by the Java. In an attempt to find such solution, Gosling and others began to work on a portable platform-independent language that could be used to produce code that would run on a variety of CPU under differing environments. This effort ultimately led to the creation of Java. What are the features of Java? The features of Java are 8. There are 8 Java buzzwords. No discussion of Java history is complete without looking at these Java buzzwords. Although the fundamental forces that necessitated the invention of Java are portability and security, other factors also played an important role in molding the final form of the language. The key considerations were summed up by the Java team in the following list of buzzwords. Number 1. Security. As desirable as dynamic network programs are, they can also be present as a serious problems in the area of security and portability. As you are likely aware, every time you download a normal program, you are taking a risk because the code you are downloading might contain a virus, Trojan horse, or harmful codes. At the core of this problem is the fact that malicious code can cause it damage because it has gained unauthorized access to the system resource. Java achieved this protection by enabling you to confine an application to Java execution environment and prevent it from accessing other part of the computer. You will see how this is done shortly. The ability to download program with degree of confidence that no harm will be done may have been the single most innovative aspect of Java. Second is portability. Portability is a major aspect of internet because there are many different types of computers and operating system connected to it. If a Java program were to be run on a virtually any computer connected to the internet, there need to be some way to enable that program to execute on different systems. In other words, a mechanism that allows the same application to be downloaded and executed by a wide variety of CPU, operating system, and browser is required. Therefore, some means of generating portable executable codes was needed. So Java used a virtual machine, a virtual environment, that is JVM, which can be installed on a target device, and any application that is compiled using Java code generates a bytecode which can be run on that JVM and can be used on any kind of targeted CPU. Third, Java is distributed. As Java is designed for distributed environment of the internet because it handles TCP and IP protocols. In fact, accessing any resources using URL is not much different from accessing a file. Java also supported remote method invocation, that is RMI. This feature enables a program to invoke methods across a network. 4. Java is simple. Java was designed to be easy for the professional programmers to learn and use effectively, assuming that you have some prior programming experience to C or C++. You will not find it hard to master if you already understand the basic concept of object-oriented programming. Learning Java will be even easier. Best of all, if you are an experienced C++ programmer. Moving to Java will require a very little effort because Java inherits C and C++ syntax and many of the object-oriented features of C++. Most programmers have little trouble learning Java. 4. 5. Robust. A multi-platform environment often places extraordinary demands on a program because the program must execute reliably in a variety of subsystems. Thus, the ability to create robust programs was given a high priority in the design of Java. To gain reliability, Java restricts you in a few key areas to force you to find mistakes early in the program development. At the same time, Java frees you from having to worry many of the most common causes of programming errors because Java is strictly typed language. Check your codes at compile time. However, it also checks your codes at runtime. Many hard to track down bugs are often turned up in hard to reproduce runtime situations are simply impossible to create in Java. Knowing that what you have written will behave in a predictable way under diverse conditions is a key feature of Java. To better understand how Java is robust, consider two of the main reasons for program failure: memory management mistakes and mishandled exception handling. Memory management can be difficult, tedious task in traditional programming environment. For example, in C++, the programmer will often manually allocate and free the dynamic memory, which sometimes lead to problem because of the programmer will either forget to free the memory that has been previously allocated or worse, try to free some memory that another part of the code is still using. Java virtually eliminates these problems by managing memory allocation and deallocation for you. 6. Java is object-oriented. Although influenced by its predecessors, Java was not designed to be source code compatible with any other language. This allowed the Java team the freedom to design with a blank slate. One outcome of this was a clean, usable, pragmatic approach to object. Java manages to strike a balance between the purist everything is an object paradigm and the pragmatists stay out of my way model. The object model in Java is simple and easy to extend, while primitive types such as integers are kept as high-performance non-objects. Interpreted. As described earlier, Java enables the creation of cross-platform programs by compiling into an intermediate representation called Java bytecode. This code can be executed on any system that implements the Java virtual machine. Most previous attempts at cross-platform solutions have done so at the expense of performance. As explained earlier, the Java bytecode was carefully designed so that it would be easy to translate directly into native machine code for a very high performance by using just-in-time compiler. Java runtime system that provide this feature lose none of the benefits of platform-independent code. So that's it with episode 1. Please don't forget to like, comment and share this video and subscribe to our YouTube channel and press the bell icon for the updates. And check out Instagram post for daily updates and follow me on Twitter. Thank you so much.